All right, guys, welcome to our Unit 4 of factoring. In this first lesson, we're going to learn about the greatest common factor, and all of the students are going to be able to factor a polynomial using the greatest common factor. That's our objective. So let's take a look at these notes. Starting in your notes, you'll notice it says greatest common factor. The greatest common factor is the highest number that divides two or more numbers exactly. Write that definition into your notes. So it's the highest number that divides two or more numbers exactly. Now, in your notes, you're going to see how do we find the GCF of numbers versus how do we find the GCF of variables. So for how to find the GCF of two numbers, make sure that you find all the factors of the two numbers and then find the largest number in each list. So my example for us to try together are the numbers 10 and 35. So I'm going to find all the factors of 10. Well, 1 goes into 10 and 1 times 10 is 10. 2 goes into 10, what's left? A 5. 3 doesn't go into 10 evenly, 4 doesn't go into 10 evenly, and 5 goes into 10 evenly, but that gets out of 2, and we would be repeating ourselves. With 35, we do a similar process. So we have 1 and 35, and then if you remember from elementary school, you go on until you get another factor, and that would be 5 and 7. So those are all the factors. I found all the factors of the two numbers. Now I want to find the largest number in each list. So you notice that they both have 1 in common, but they also both have 5 in common. Which one is larger? 5. So our GCF of 10 and 35, not GFC, but GCF is going to be 5. Now, how do we find the GCF of two variables? So in your notes, write this down. This is extremely important. The GCF is the variable with the lowest exponent. Let's talk about that for a moment. Well, if you took this example, write it into your notes of x cubed and x to the fifth, all right, x cubed is the same as x times x times x. X to the fifth is the same as x times x times x times x times x. All right, your GCF has to be in common. It's the greatest common factor. Well, how many x's do you have in common? 1, 2, 3. That's the greatest amount of x's in common to both of those terms. So that means our GCF of these variables is x cubed. Now let's kind of put it together. So here's our first example. We've got 28x cubed minus 7x. I like to look at the coefficients first. All right, so I've got 28 and I've got 7. The factors of 28 are 1 and 28, 2 and 14. 3 does not go in, but 4 does and 7 does. 5, 6, oh, we're back to 7, so we stop. With 7, we've got 1 and 7. So our GCF there, the greatest common factor of our numbers, is going to definitely be 7. So we know that our 7 is going to come out. All right, now let's talk about the x's. Well, we've got an x cubed here and an x over here. Notice again from our notes, it said that the greatest common factor of variables is the variable with the lowest exponent. What has the lowest exponent? X. So now what we have left, so our GCF, by the way, is 7x. That's the biggest amount of numbers and variables that we can take out. What's left inside, we kind of call our trash. So if we took out a 7, we're left with 4 more. Okay, if we take out an x from an x cubed, well, originally x cubed is 3x's. We take out an x, how many am I left with? X squared. The minus sign just carries down. All right, I'm left with a 1 when I take out my 7. And if I take out my x's, I'm left with no x's. So this you can kind of think of as your trash. So you took out the trash, and what do you got left? Let's do another example. If you feel comfortable, you can skip my explanation and move on, but make sure you're comfortable with how to find this. So now we have 3 numbers, 3, 12, and negative 21. So the factors of 3 are 1 and 3. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. You might be asking yourself, do I have to do all this listing if I already know what my greatest common factor is? Absolutely not. You can move on ahead. But I'm just showing you for the purpose of this video. 1 and 21 are the factors of 21, and 3 and 7. So the biggest number that all three of these terms have in common is the 3. So that's going to be our coefficient that we're taking out. Then we have x to the fourth, x cubed, and x. So the one with the smallest exponent is what we take out. That's x. And what does that leave us with? Our trash. So we took out a 3, we're left with a 1. We took out an x, so we're left with an x cubed. Plus sign, because that's exactly what it says. That has not changed. We're left with a 4 left over. We took out an x, so we're left with an x squared. The minus sign just comes on down. We took out a 3 from the 21, so we're left with 7. We took out an x from the x, so there's no more x's there. So we have our GCF of 3x, and we have our trash that's left over. Okay? If you look at those notes that I gave you, all right, what if the leading coefficient is negative? Write this into your notes. If the leading coefficient is negative, your GCF will be negative. If your GCF is negative, all the signs of the polynomial in the trash will switch. So let's go ahead and take a look at this example together. Again, if you feel comfortable, pause it, try it yourself, and then move on. So notice your leading coefficient of -2, it's negative. So what does that mean? Our GCF is going to be negative. So with -2, the only factors are 1 and -2. This is going to be the biggest number that you're going to take out of all of these because all three of these numbers are even. So we're going to take out a -2. We look at our x's. We've got x to the fourth, x cubed, and x squared. The smallest amount of the exponents is x squared, so that's what we have to take out. Okay, what's left inside is our trash. So what do we have left? We've got a 1. We took out 2 of our x's, leaving us with an x squared. Okay, notice how my sign changed from a negative to a positive because it said to switch all signs here, right? Because if 10 divided by -2, it's going to be -5. I've taken out 2 of my x's, so I'm just left with a plain old x. Okay, and then a -14 divided by -2 becomes a +7. We're switching all the signs there, leaving us with 7. We took out all of my x squareds there, and there you have it. So your GCF would be -2x squared, and your trash is left right here. And that's what's left over. No, you don't have to write GCF and trash every time. So, when are we going to use the GCF? Well, you should always think about it the first thought that you have when we're factoring. And we'll talk more about that in our second lesson. But it's your first thought when you're factoring. Okay? This should say whenever there is a GCF other than 1. So whenever your leading coefficient is something other than 1, you definitely need to take out that GCF. So that's when we have to use it. Go ahead and try this last example on your own and bring any questions that you have to class. When you're ready, you can stop the video, try the problem, and when you're ready, press play to see the explanation. Hopefully you're able to figure out the problem. Notice my GCF should have been 3x, and my trash, not my GCF, that's labeled again, my trash should have been 5x cubed plus 3x minus 1. So there is my fully factored form for now, and we'll talk more about how to go further with factoring next class.